Hey guys, welcome to the video on rate of change. In this video, we'll understand what is rate of change and what are limits. Functions are represented on a line on a graph. We will create a function between velocity and time. For example, suppose the function f is used to calculate the number of meters traveled by a car in given number of seconds. Here is a chart for this function which shows you how far the car has traveled on the y-axis against the time taken in the x-axis. Now when we look at this chart for this function, you can see that it's curved. That means that car is not traveling at a constant speed, but it is accelerating. Well, you can find the average rate of change over a part of this function by drawing a straight line. It is called a secant line, and it joins the 2 points on the function. Then we calculate the slope for the secant line. In this case, our x values are 3 and 1. Using these values, we'll measure the slope of the line. We calculate the deltas by taking 2 points on the line, subtracting the y and x values from these 2 points, and then dividing. In this case, our 2 points are 3 and 1, which make the value as 10 minus 2 by 3 minus 1. And it gives the deltas of 8 and 2. 8 divided by 2 is 4. So the average velocity between these 2 points on the function line is 4 meters per second. And for every increase in x unit along the secant line, we increase y by 4 unit. And this is how we find the average rate of change between 2 points on a curve. But what if I need to find the exact rate of change on a single point when, let's say, x approaches to a point 3, both from below and from the top? What we need is an ability to find the slope of a curve at that point. Symbolically, we call this as a limit of a function as x approaches that point, in this case when x approaches 3. We will talk more about this in our next video on differentiation. Okay then, let's jump into the Jupyter notebooks and see what are the functions that are available to us to find out limits. So here we'll use a new library called SymPy that helps us with a lot of different libraries that help us in differentiation, integration, and finding the limits. Now here we will define our symbols and our expression. So first we'll find out the value of cos x when x approaches to 0. Now this is the graph of cos and sine functions, and we see when x approaches 0, the value of cos x is 1. Now we'll check the output from our limit function. Now when we run this cell, we see the limit of the expression when x tends to 0 is 1. Likewise, you can use other different functions, other different symbols, and find their limits. So guys, this was about limits. In our next video, we'll talk about differentiation. So stay tuned.